So now I'm going to be using truth tables to show validity or invalidity of different arguments. So let's look at the first argument. A or B, not B, therefore A. Let's say we see a really fluffy dog, and we know it's either a poodle or a Bichon. The dog owner tells us it's not a Bichon, so then we know it must be a poodle. Okay, so A and B, just like the truth table for the statement with two propositions within it. We have A can be true and B can be true. A can be true and B can be false. A can be false and B can be true. And both A and B can be false. Those are all real possibilities. Now, what we're going to want to do is in the middle of the truth table, we put the premises of the argument. One of the premises is A or B. Another premise, the second premise, is not B. And finally, in the third area, we put the conclusion, which in this case is going to be A. See, the conclusion is what the premises are supposed to prove in an argument, right? So here we have the two premises, and here we have the conclusion, right? So let's analyze for the premises. Well, a disjunction is true if the first part is true and the second part is true. So when A or B are both true, then A or B is true. A or B is also true if A is true and B is false, or if B is true and A is false. In fact, A or B is only ever false when both A and B are false. Now let's look at not B. Clearly, not B is going to be false when B is true, and it's going to be true when B is false. So we're going to have something that looks like this. False, true, false, true. Now we're going to do the final row, which is for the conclusion, which is just the same as the A column. So we have true, true. These are both true, and false, false. So what are we trying to show here? Well, we're trying to show validity, right? And validity shows you that the premises follow from the conclusion, right? And what that means basically is the conclusion is supposedly proven by the premises. What that means is if the premises are true, and if the argument's valid, then we know the conclusion is going to be true. So what we're looking for if we're testing for validity is a row where the conclusions are, or where both the premises are true. We're going to be saying, is the conclusion also true? If both of the premises aren't true, then that particular row doesn't matter. We only care if both premises are true. So here we have A or B and not B, right? Where A or B is true, but not B is false. So that row doesn't matter. Now let's look at the next row. Both premises are true. And is the conclusion true or false? Well, here the conclusion is true. So you can underline this row. Here, the premises prove the conclusion. Right? The conclusion is true and both premises are true. Now let's look at this row. Well, here again, one is true and the other is false, so that row doesn't matter. And finally, the bottom row, one is false and the other is true, so again, that row doesn't matter. So we would say that this is a valid argument. And it's a valid argument because the premises lead to the conclusion. Or put another way, the conclusion follows from the premises. Simply that whenever the premises are true, we also know that the conclusion is going to be true. Now let's look at the next argument. A and B, A or B, A, therefore not B. Okay, so here we set it up the same way. True, 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 false, false, true, and false, false. A or B is going to look the same. We get true, 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 false. A is going to be the same as the first row. Here we have true, true, false, false. And not B, well look, when A or B is true, then not B is going to be false. When A is true and B is false, then not B is going to be true. When A is false and B is true, then not B is going to be false. And finally, when both A and B are false, then not B is going to be true. So here again, we're going to be looking for rows where both of the premises are true. And there's two rows where both of the premises are true for this argument. There's the second row, here, and there's the first row. So does the conclusion follow from the premises? It seems if A is true and B is false, then both the premises are true and the conclusion is false. So in that case, it seems like maybe the conclusion follows from the premises. But actually, that's not true. Because if you look at the first row, here the premises are true, but the conclusion is false. And when the premises are true, but the conclusion is false, we know the argument must be invalid. Because in that case, it's not true that we know that the conclusion is true just because the premises are true. So we say this argument, A or B, A therefore not B, is invalid. This is an invalid argument. And you can replicate this strategy for all sorts of other truth tables. So finally, I'm going to look at a slightly more complicated problem. Here we have three letters, right? Three different propositions. We have A, B, and C. Okay? And here we have a first premise, which is if A, then B. Then we have a second premise, if B, then C. And finally, we have this final premise, if A, then C. And so let's see if this is a valid argument or an invalid argument. First, we note that we have three different propositions here. So we're going to need more than just four different rows. There's a situation where A is true, where B is true, and where C is true. Right? There's also a situation where A is true, and B is true, and C is false. There's a situation where A is true, B is false, and C is true. And there's a situation where A is true, and both B and C are false. Right? Now we have a situation where A is false, and B and C are both true. We have a situation where A is false, B is true, and C is false. We have a situation where A is false, and B is false, and C is true. And finally, we have a situation where all three are false. A, B, and C are all false. So if you notice, there are now 8 different rows. With a truth table that has 2 letters in it, we're only going to be having 4 rows. And if there's 1 letter, we're only going to have 2 rows. So a good way to think about it is that the number of rows you need is basically 2 to the power of n, where n is the number of variables you have. Here we have 8 rows. 2 to the power of 3 is 8. So this is 8 rows, right? Okay. It's going to take a little bit more time to solve, but it's basically the same process. It's not any harder in substance. So we solve these the same way we did for the others. So if A then B. If A then B is false when A is true and B is false. So here, A is true and B is false. So it's going to be false in both of these situations. In all the other situations, if A then B is true. True, true. True, 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 true. B then C is the same. When B is true and C is false, we have a false. Right? B is true and C is false, we have a false here. When B is true and C is false, we have another false here. And once again, all the others are true. So we look at the final one. When A is true, then C is true. That is going to be false when A is true and C is false. So here we have a false, and here we have a false. And the others are all true. So now we have to go through and look at all the rows where all the premises are true and the conclusion is either true or false. So here we have both premises are false and the conclusion is, here we have both premises are true and the conclusion is true. Here, one premises is true and the other premise is false. Here, one premise is false and the other is true. Same here. And here we have another row where both premises are true and the conclusion is true. So, we also circle this one. And finally, look here on the bottom. You have two more rows where both premises are true. So we'll circle these. Now remember, what we're going to look for is a row where the premises are true and the conclusion is false. So is the conclusion false for any of these four rows? Here we have a true conclusion. Here we have a true conclusion. And in these two we have a true conclusion as well. So we say that this argument is valid. This argument is actually a famous syllogism in logic. It's called the hypothetical syllogism. I think it's in the lecture notes. The other argument we saw that's valid is also a famous syllogism. It's called the disjunctive syllogism. That's if A, then B, not A, therefore B, or if A or B, if not B, therefore A. These two we know are valid. This is a disjunctive syllogism. The invalid argument we saw, A or B, A therefore not B, right, this is the invalid one. This is a commonly known logical fallacy. So here we learn three valid syllogisms and one fallacious argument. Because these are both valid and this is invalid. And we show that with truth tables. Again, just a quick review by checking to see when the premises are true and see whether or not the conclusion is also true.